analyzed cost to energy efficiency, and we're able to prove that the computer can design a building that is cheaper to build and saves a lot of energy. Right? I mean, that is the classic ultimate in engineering, right?
It is.
You would not want to live in this building.
Welcome to the Fine Homebuilding Pro Talk podcast, a regular discussion with building industry professionals. This is Senior Editor Patrick McComb. This is the second half of my interview with engineer Paul Torcellini, who works at the National Renewable Energy Laboratory. You can find the Fine Homebuilding Pro Talk podcast and the original Fine Homebuilding podcast at finehomebuilding.com/podcast. You can leave feedback and ask questions there too. I think you'd agree that there's less embodied energy in an existing building and therefore, greener. But you build a new home for yourself. Can you first tell me about the house and how do you justify building new when there are so many existing homes that could be improved?
Yeah, so, I mean, there's a couple
I didn't mean to hit you with both barrels there.
No. That's kind of like me bothering you about your coffee in the morning, right? So, yes, we built a new house. We designed it, so that it would be highly passive solar. We looked at the orientation. We focused on the envelope. We put in very little heating and cooling systems.
Is it forced air? How are you heating it?
So predominantly it's passive solar, which becomes a big part of it. And then I've got a air to water heat pump that provides heating both to my domestic hot water as well as to a radiant slab or a radiant floor system. It's actually underfloor radiant heat. But just to give you some perspective, the house on the coldest day of the year, the design load is something under 25,000 BTUs an hour. So, that comes down to, a handful of hair dryers kind of number. And so that's where the big difference is in doing that. In fact, there's maybe some funny stories about the radiant heating. We also have a mini split unit. And again, because the walls are so well insulated, I have one head in the living room. I can heat the whole house with that 1.5 ton mini split if I want to. So I actually have two different heating systems.
Yeah.
That also provides some dehumidification if I need it. It wasn't an afterthought, but it wasn't in our initial plan to put that in. That was more.
You added it for the air conditioning, can I assume?
No, because I'd actually figured out that, we could get enough kind of night cooling and close the house up and let it ride through the next day because it's so efficient. It was actually driven by a utility incentive. And in order to get the utility incentive, I had to show that I had efficient heating and air conditioning, because otherwise they made the assumption that I might stick window air conditioners in, which would be terribly inefficient. And so at the end of the day,
I hear they're not that bad.
Yeah, yes and no, right? I mean, look at how they get installed, and they got lots of cracks and leaks around them, right? In terms of, kind of going back to your school example, because they're loud, they're kind of in your face. People go in, they turn them on, and when they leave, they tend to turn them off, right?
And you're cooling spaces instead of the entire home, I think, is what I've heard.
You're cooling the people,
yeah,
right? Or an immediate need as opposed to the entire building. That's another one I see, especially in schools where they move from window air conditioners and suddenly they put in a central air conditioner. And again, their bills go up. Why? Because they're now conditioning everything and not just a part of it. Can
you explain your air to water heat pump? Frankly, that's a system that I am not familiar with.
Sure.
Who makes it? How big is it?
So it's if you're familiar with kind of a normal heat pump mini split inverter, it's about the same size. Those are what's called let's talk about a regular air conditioning system. Has a unit that's outdoors, has refrigerant lines that run from that outdoor unit to something indoors, and it moves the energy with that refrigerant. Okay, so in the summertime, it sucks the heat out of the house. The refrigerant carries it outside, and then that is sent to the outside world as hot air, right? In heating mode, if you have a heat pump, it takes heat from the cold or outdoor air, puts it into that refrigerant. That refrigerant is moved to the inside of the house, and that heat is released, right? In this case, we take the heat from outside in the air and actually put it directly into water in a unit that sits outside the house. And then that water is circulated between inside, outside, or outside.
What's the
Outside,
advantage versus air to air?
Um, so in this case, it's directly making hot water, and I can use the hot water for showers and things primarily. And when you start looking at energy loads for these highly efficient houses, it is dominated by hot water. And so in some ways we make that hot water, and then we kind of skim off that hot water to heat the house also. And it is, especially in the summertime, it is a highly efficient mechanism to make domestic hot water because it's hot outside, and all we have to do is raise the temperature of water, say from 80 degrees to 140, which is pretty easy for a heat pump to do. There are a couple different manufacturers on the market that make this, especially when you start moving into like multifamily. And it really, the market it's replacing is kind of the traditional either electric resistance hot water or say gas or oil fired hot water.
And who are the makers of these things?
So Mitsubishi is going to be coming out with one that's on the market. Sandin is one of the manufacturers of that.
Is that what you have, right? Their CO2 is the refrigerant, right?
CO2 unit. And the Mitsubishi unit is also CO2. Let's see, other manufacturers. So Comac, Nile. I don't like doing this because I'll inevitably forget somebody. Shark makes one for drain water heat recovery, sewer water heat recovery, which is kind of clever.
And that's on a utility scale? Is that how that works?
These are on a kind of it's commercial building scale, most of these.
In a question, in an article about your house in High Performance Building magazine, you described your home's heating system. The space heating system is a 1.5 ton air-to-water heat pump using CO2 for the refrigerant. This provides heat to the 12-zone radiant floor system. Only an engineer could do that, right? Why 12 zones?
Well, some of it is when you do radiant floors, you're kind of limited to about 300 feet for the tubing length, which happens to be pretty close to a room. And so it kind of makes a natural system out of it.
Do you have circulators on every one of these zones?
No. There's one circulator, and then there's a manifold with valves on it. What is interesting about it, I had used this system in a previous house, which was gas-fired. The house was older. It needed a lot more heat than this one does. What's kind of interesting about the radiant was that in the old house, we had to run the water pretty warm to keep the house warm. So, the idea that the floors really felt warm. In this house, the floors are much cooler because otherwise we'd bake ourselves out of the house. So you don't necessarily feel quite as much warmth with it. The other part is, in the old house, we actually zoned every room separately. Because the envelope is so tight in this house, we actually don't need individual zone valves at the end of the day. So there may have been better ways to install this at the end of the day, just because, once you put heat somewhere into a house that's so energy efficient, it kind of distributes around the house naturally. Right.
That's the kind of comfort thing we always talk about in high performance homes, right? You don't have cold surfaces, you don't have drafts.
Right. Well, and the notion, even if you're using forced air, that you don't have to put ductwork out to under every window. Yeah. Right. And so you can save money with shorter duct runs and not putting duct runs in the attic, and that you can distribute it much more uniformly, and it's easier. You kind of think about it, if you break a bottle of perfume somewhere in the house, that smell permeates very quickly around the house, right? It's kind of the same with the heat in the air. When you get really good tight walls, it does the same thing. You just put a little heat into one part, and it kind of finds its way to the whole house.
So what part of your home did you build yourself, and what did you have subcontractors or contractors do?
Yeah, so I acted as the general contractor. I did the design, um, and we hired somebody to do the site work, the septic, the well, the foundation, um, the framing. We hired a framing crew to do the whole, all the framing, up through siding. Let's say, I should probably go the other way. Anyway, the insulation, we hired somebody to put in the insulation, and all the drywall work. I did the electrical and the plumbing predominantly in the house. And then we did a lot of the finish. So we put in um, all of the flooring products and things like that. Some of it is that we were also, you know, in order to keep air quality up, anything you bring into a house, you have to think about what is it going to off gas. And that's something that we don't, and if you bring pollutants in, you then have to ventilate the house to get those pollutants out.
Which
right?
is contrary to your energy goals, right?
Right. Well, and it's one thing to talk about, pollutants that we give off, carbon dioxide, replacing oxygen. You've got to bring in oxygen, it's a whole nother thing when you start bringing in, chemicals into the house that then outgas. And so we were very sensitive to that. And again, some of it was just the product. So everything that came in was as natural as possible. To prevent that outgassing. So, the wood floors got finished with a tung oil that had a citrus carrier with it, so that you didn't have, any kind of a petroleum product off-gassing with those things. The paints were non-latex based paints.
What do you use if it's not latex?
It's a mineral-based paint is what we ended up using in the house. And it works well with the plaster. It was a plaster skim coat on the walls. So everything, all of the kind of resilient flooring. If it weren't tile, there's a little bit of tile in the bathrooms, but we used real linoleum with cork backing. And again, products, really thinking about and studying what the outgassing was. The funny thing is that you put this stuff into the house and it doesn't have that new house smell. People joke about the new car smell. Well,
yeah, those are chemicals.
Outgassing, right?
Those are plasticizers that smell good.
Right. So we try to avoid all of those kinds of things in the house.
What do you think about the state of residential building in this country? Are we doing a good job? Do you like what you see when you drive around?
It's all over the board.
Yeah.
Right. And so there are lots of builders that are doing a really good job guaranteeing energy performance, getting houses ready for electric vehicles, even just putting in the circuit into the garage to be able to handle that kind of load. If they don't put the PV on, wiring for PV, doing blower door tests to make sure that they meet, certain performance levels and standards with that. They're really, there are definitely a lot of builders that have really embraced that. There's also a lot of construction going on where, somebody comes in with a drill bit for the electrical and they're like, one drill bit solves every problem, right? And and it doesn't matter what you're going to put through that, and then nobody really comes back and seals those things up, and it wouldn't pass a blower door test, but since it wasn't done, nobody knows, right? And so there are definitely builders that are doing a really good job. The challenge is that consumers need to kind of demand that level of excellence, right? At the same, it's a big investment for people, and to tell people, you should have blower door tests done, and actually show that it's tight is important.
Do you think commercial buildings are making similar strides? And
they are, and it's probably bigger strides at this point, because I would say they were further behind. And it's the same things, right? How do you get materials to kind of butt up against each other and get good seals in there? How do you guarantee the envelope performance so that you can really put in an effective heating and cooling system? And think differently about the heating and cooling system, right? To move to something like radiant ceiling panels, you've got to make sure that you don't have a lot of loads. Again, it was that philosophy of heat the people, not the space, with a radiant source, both heating and cooling, right? Well, you've got to have a really good envelope to make those systems work. But then you can move energy with a little bit of water instead of a lot of air, right? Which is more energy efficient. So, and again, there are builders that have embraced this. There are design teams that have really figured out kind of the cost model and how to kind of sell this and make it work. And I talked about some of the research projects. It's still kind of, I don't want to say, I mean, it's kind of still in the noise, right? It's still a very small fraction of what we build, but at least we've got lots of good examples, right? So if people are interested in doing this, right, there are thousands of zero energy houses to look at. There's, in the hundreds of kind of zero energy buildings out there that people can use as examples today.
What do you think about your own home after you lived in it 3 years now, 4 years?
Yeah, I think we're closer to 6 now as time flies.
Would you do anything different?
Would I do anything different? We're pretty happy with it. I think, I would have, I'm COVID wise, I'm working in a, kind of a basement room, which we didn't really plan on, at that point. So I probably would have thought of that a little differently in terms of, conditioning it and getting, the energy here to this space. There's always, things like when I built the house, I looked up to figure out how big to put in an electric car charging station. And I think I put a 30 amp circuit and wire to the garage. Well, that's, I was like, it should have been a 60 amp circuit today, right, to make it work. Those kinds of things. And of course, fishing wire between the panel box and that is difficult.
Those are big wires too. That makes it more difficult. Yeah.
Right. But it wasn't on, the radar screen, to do that. I may have thought differently around using maybe more mini splits or a couple of mini splits instead of the radiant floors. The radiant floors are nice, but it's not.
It's an expensive system. I think you'd agree.
It's an expense, and what helped with that is that I installed that. Mm-hmm. I got a couple of helpers, and we were able to put that up on the floors pretty quickly, as opposed to hiring somebody to install it. But at the end of the day, if you were going to do this and reproduce it and show a business model, you do it because you want to do it. It's not because it's
the most cost
effective or the most energy efficient solution. There are other systems that are less expensive, but at the end of the day, and this is one of my messages too. We spend money on all kinds of things, and and we spend money to waste energy as well.
Yeah, like you buy a hot tub, for example.
Right.
Yeah.
Right. And those are things that we want. They're amenities that we want, and that's okay. Right. It's a matter of how to do that in the most efficient way.
The engineer must think that's not okay, though, right? How do you rectify that?
I think that I probably think a little more out of the box than most at trying to think about, how are we going to move whole markets and move the building industry? And there's lots of players involved, lots of people that make decisions, like we talked about earlier. And it's not purely a numbers game, right? We've done computer models where we've analyzed cost to energy efficiency, and we're able to prove that the computer can design a building that is cheaper to build and saves a lot of energy, right? That is the classic ultimate in engineering, right?
It is.
You would not want to live in this building. Right? You would not want to be in this building. Why? because it puts a really thin strip of glass around the top of every outside wall because the daylighting has very high value, right? So, and that's the only really cost-effective piece of glass, except if you need the passive solar heating. So then all the glass would be on the south side of the house, and you wouldn't have any windows anywhere else because it is so inexpensive now to put in an LED light to light your space that the notion of having a window to bring in daylighting, I was like, that's a great amenity. I mean, you can look outside, you like the sunshine that comes in. The computer says, no way, right? Which means, I guess, the engineer says, no way. I mean, that's not a way to move, markets, because people don't want that. But we can design and have architecture that people want to be in, that enjoy being in, that is highly comfortable, highly cost effective, at the end of the day, and really think about shifting how buildings use energy.
Something I've wondered about, COVID has changed the way we buy things, right? I read a piece written by a person who was a picker in an Amazon warehouse. They didn't say it was Amazon, but it was Amazon, I'm sure. And this person walked 12 miles a day to pick the many things that we buy from Amazon, right? Is it better to have a huge building like that versus, hundreds of retailers in every town in America from an energy standpoint? I imagine the Amazon warehouse is only minimally lit. It's probably minimally conditioned. Obviously, there are good reasons to have stores on Main Street and places where people can shop locally, but from an energy perspective, is that a better model?
I haven't really studied, that piece of it, and which makes more sense, like if you trace a product from where it starts to where it ends and all of the, steps it has to go through, in that model, you're going to rely on delivery trucks, right? I mean, your favorite company of delivery trucks stops by here every couple of days.
There are a dozen of them that come in my neighborhood every day. Right. And because I sit at the end of the street and watch them come in the neighborhood.
Yeah. So, especially if you're in a neighborhood where they can drop off lots of them, it may be because, it's always what we call that last mile. That's the toughest part of it, right? So the alternative is that you get in your car and you drive across town to a store. Probably the biggest impact on that product is you driving to the store to get it, right? And likewise, putting it into a small delivery truck and delivering it.
Even compared to the building that is, used not all the time, but it's conditioned all the time, and it's all artificially lit because there are no windows. Even taking that into account, the worst part is driving to get the thing at the end of the day.
That's my gut feel again. That the engineer could probably sit back and figure all those pieces out, and I think we'll think about that. One way to think about that is which is a more cost-effective model at the end of the day. Right. And there's other things at play that we don't think about as well. Your smartphone is only smart because there's a lot of data centers behind it. Mm-hmm. Right. And today data centers, I want to say it's something like 2% of the energy.
It's insane, right? I read about a Google server farm and the energy use is crazy.
Yeah. So, that you have to take that into account too. Right. I mean, I always find it interesting, the discussion about having a smart controller on your light that then goes to your router, that then goes to the cloud, that then comes back to your cell phone, which has to be charged.
You could have just turned the switch.
So you can turn on and off your light, your 6-watt light from your cell phone, but how much energy did that really take? Kind of thing. We will learn a lot more about those technologies, right, as they mature. And so I wouldn't get, I'm not too focused on that. I tend to think more about things like, going back to the energy you have is really the energy that falls on, say, your piece of property or your house, right? So you say, well, the house is pretty easy, right? Even though we still struggle with it, right? I can put solar panels on my roof. I can power my house because it's very energy efficient. If I add an electric car to that, I need like 30% more solar panels to run my car, right? Well, maybe I can put those on my carport or my garage, kind of thing. And I can imagine doing that. When you start getting into things like food, let's just do food for a moment, right? How much land would you need behind your house to grow everything you eat? Because that's that stored sunshine, right? Whether it's vegetable products or vegetable products that then go into meat products, right? I mean, what do how much of that do you actually grow on your site? I mean, that's not having, and yeah, it helps to have, a tomato plant that you can grow some tomatoes on it. And that clearly is a lower environmental impact than trucking tomatoes from, say, the West Coast to the East Coast.
Right? Or
Mexico,
yeah.
or, getting bananas whenever you want bananas, right? Those things have an environmental impact as opposed to thinking about growing local, eating local, going to local farmers markets. That kind of stuff has a significant, energy and environmental impact as well, right? So you can kind of, at least you can think about that. One of my goals here was how much of my own food can we grow, right? And so we run a little kind of, self-consumption sustainable farm here, and we've got all kinds of animals and plants and things running around. And we take a very conscious effort to do that, again, partly because what I do and kind of what I want to study and think about. Because again, if some of my things, if I can't do it, how can I expect other people to do it, right?
Sure.
But it's that part is really hard, right? The house was easy, right? So let's attack the house, right? And the question of the 40% of the nation's energy that goes into buildings, I think we can have a pretty good handle on, right? The other pieces become much harder. You start talking about food, and then you start talking about all kinds of other products, goods, and services, right? We do have, DOE does have programs around energy efficiency for manufacturing facilities, right? And how to reduce their energy inputs in order to make products, right? Because and then how do you provide renewable energy to those facilities, right? I mean, even take something like steel. If I can take steel and melt it down with, and melt recycled steel with an all renewable power grid, or, from a wind farm to run that steel mill, that piece of steel has a much lower impact than, say, a piece of steel that had to come out of virgin material that then was powered with, either direct coal or a coal power plant, right?
I grew up in Pittsburgh, Paul. It is hard for me to imagine how many PV panels it would take to run an electric furnace. Yeah. It's mind-blowing.
Well, and that's, that is kind of the scale, the mind-blowing, when you really start thinking about the scale of what we've got, it's pretty impressive, right? Infrastructure. And that's also why not only is it utilities trying to put more renewables online, you've got places like Colorado that there are times of the year where the majority of the power now is coming from wind, right? You can't do that in the Southeast. There is no wind in the Southeast. Doesn't make sense. But it's starting to come. But on the other side of it, we can accelerate that with what we do on every decision we make about buildings and how we design buildings and how we renovate buildings. That also can have a huge impact. So, we have to hit it from all directions. There's not an easy solution here.
Do you think the next generation is going to embrace this more than ours? I think you'd agree that we're still on the kind of fringe of thinking about these things. Are the young folks going to be better at it?
I certainly hope so.
Yeah.
I think there's a lot more awareness today around a lot of these things, but it does come down to, everybody that's listening saying, okay, what conscious decision can I make? And again, it kind of goes to those decisions, right? Is every light in my house an LED light today? Right? Is, can I buy, food from a local food, farmer's market? Let my, don't just talk about it. You've got to let your dollars, do some of the talking there, right?
Sure.
Have I thought about, buying an electric car, or when I'm shopping for a house, do I ask the questions about, is it energy efficient? Does it have solar panels on it? Can I put solar panels on it? right? All depending on the scale. That kind of goes back to the coffee cup discussion, right? Am I using refillable coffee cups, right? Because that's an important piece of this.
It has been a pleasure talking to you, Paul. Is there anything you'd like to ask or tell our listeners before we go?
No, I think that it's been incredibly exciting kind of watching this field over the last 30 plus years. And that it is time for change, and that we can all make a difference, right, in how this goes, right, and learn as much as we can about this. And like I said, everybody can make decisions, right, to make us more sustainable in our built environment and in our world.
That was fantastic. You were great. I'm really, really grateful for your time. Thank you.
You're welcome. Thanks for having me.
Well, unfortunately, that is all the time we have for today. Thanks to Paul for joining us, and thanks to all of you for listening. Please remember to send us your comments, questions, and suggestions to fhbpodcast@taunton.com. And please like, comment, or review us however you're listening. It helps other folks find our podcast. Stay safe, everybody. Thanks very much for listening. Keep craft alive.